Hello and welcome to another episode or another webinar in our series on what's new in SAP HANA 2.0 SPS 8. Today, we are going to talk about the latest new machine learning functionalities in PAL and APL or AFL, and as well about spatial enhancements and more in multimodal. We have two product managers from SAP HANA team. And without further ado, let me hand this over to Shabana.
Perfect. Thank you, Vitaly. And hello, everyone. Thank you so much for joining us today. So like Vitaly mentioned, this is going to be an overview on what's new in the SPS 08 version of the HANA on-prem systems with multimodal and machine learning. The agenda would be like, I will be first talking about some of the recent upgrades that you could now access on the spatial engine in the multimodal area, and then Christoph will take over to talk more on the machine learning and AI aspects. With that, let's get started. Like I said, with the multimodal, especially in the spatial area, we have added capabilities that would make it easier to work with spatial data, like in broader range of applications, and we will be going through a few of the functions that are now available on the SPS 08 of HANA. So let's start with the first function on screen here, the ST as S3 JSON function. So this would help you convert the spatial data into S3 JSON format, which is specifically tailored for compatibility with the S3 software, right? So one of the leading tools for spatial data analysis and mapping. So this means that if you are working with any S3 tools, or you need to share your spatial data across different platforms, so this function would make it much more straightforward for you. So now you can easily format the spatial data in a way that's readable by the S3 software without any complex transformation. So this especially is also very much helpful in cross-collaborative environments, I would say, where data needs to be flowing easily between the HANA and the S3-based systems. As you could see on the screen, that's a quick example of how the S3 JSON format would look like and how your different attributes in the spatial domain could be mapped in the S3 JSON format. We'll have a quick demo also on that. The next function is the ST intersects rectplanar function, which would allow you to check if the geometry intersects within or intersects with a specific rectangular planar area. So you could think of it like a boundary checker for your spatial data. So this function is especially useful when you're dealing with spatial queries that require you to have accuracy in defining points or geometries that would fall within a certain boundary. For instance, you could think of it like if you want to find areas which would intersect a particular defined zone, such as points that could be intersecting within with a city block or boundaries in a property map and so on. So this is a good way for you to already check efficiently and accurately how your geometries are intersecting a particular rectangular plane. On to the next function, the 3D length, which would help you calculate the 3D length of the lines, taking into account also the Z coordinate. Which means you are not only looking at the length in a flat plane, but also considering with respect to the elevation or depth of that line. So this is particularly useful for industries or use cases where elevation matters, like in constructions, mining, or environmental monitoring use cases. And if you're working with pipelines, for example, in utilities, that varies in depth, or analyzing the flight paths with respect to the altitude differences and so on, ST3D length would allow you to get more accurate measurements now, with also considering the Z coordinate, right? So it becomes a little bit straightforward to add depth to your spatial analysis, literally. And next we have the ST remove point. So this function allows you to remove a specific point from a line string by specifying its index. So you can think of it as a simple but a nice editing tool within your spatial workflows. So it's essentially that counterpart to your existing another function in spatial, the st_add_point function. So you can add any point using that function, but now you also have a capability to remove the points that you won't need. So that means you get more flexibility in refining your geometries. And this feature is also particularly helpful when you need precision in adjusting your paths or simplifying the geometries by eliminating any unnecessary points. So that's what it is especially made for. Okay, so in here we'll be talking about two important upgrades with the spatial functionality. That's a new intersection algorithm for clustering and an update to the st_centroid function on the right. So starting with the intersection algorithm, this new feature would help you to support clustering of various geometries, including polygons, points, lines, and even collections of multiple of different shapes. So what this algorithm does is it identifies the connected components within the data. Simply put, in a simple manner, it helps you find clusters of geometries that intersect or are spatially connected. So this is very valuable in scenarios where you want to analyze or group areas that overlap or are very closer to each other. So like identifying clusters of region with similar characteristics or detecting neighborhoods based on geographic features and so on. One thing to mention here, that these geometries don't intersect, like you want to find geometries that don't intersect with any others, or in the sense of finding outliers, I would say, where you want to automatically flag some geometries where they don't fall in your group or so on. So this intersection algorithm comes in very handy in such scenarios. And the other one on the right, the st_centroid function, it's more of an update to that. It's already available on the on-prem systems, but now, like previously, let's step back. So previously, this function only supported the flat spatial reference systems, right? So which was kind of limiting its use for global data. So, but now with the SPS 08 release, we are also supporting the round earth spatial reference systems with the st_centroid functions, which mean you can calculate centroids on a model that better reflects the actual shape of the earth itself, like on the round earth. So this upgrade is particularly helpful in applications that involve geographic analysis over large areas, or if you want to improve the accuracy of the centroid calculation overall on the round earth scenarios. So the last couple things that I wanted to quote, we have a new system view which is called MST geometry columns, which would provide metadata on your geometry columns, which is very helpful for managing and visualizing your spatial data across different tables and schemas. You get an entire overview on it, like with this new system view just being executed. It gives you a quick overview of the spatial attributes, like including minimum and maximum values for X, Y, Z and M coordinates. This is also helpful in working with large data sets with multiple geometry columns, because it is allowing our users to understand the spatial bounds and the properties of their data just at a glance. And next we have the st_Hausdorff distance function, which means a worst case distance between two geometries that you could find now. So this function is also helpful for comparing shapes to identify dissimilarities, basically. So for example, if you're tracking changes in a geographical boundaries over time, like it could be shifts in coastline or shifts in borders. So this function gives a better metric for calculating the maximum distance between two geometries, like which helps in assessing how significantly one shape deviates from the other. So it's a very useful tool for applications where you want to see exact alignment or similarity of the shapes is being critical. So it comes in very handy, especially for environmental monitoring or in case of urban planning. So those are all the functions that have now made it to the on-prem systems, SPS 08. I also wanted to quickly top it off with some demos. So moving on to my demo screen right here. So for the demo purpose, I have already created a table called as Spatial Demo, which has a geometry column included, which is a round earth geometry column. As you could see, I have specified it, and I have already added some records into it, which consists of various geometry shapes, like it could be points, line strings. I have some polygons in here. I have multi-points, all sort of things. So this is the table. I have already performed a select on this, so you could see all of those geometries that I have. So some rectangles, some lines, points, and multi-points, as I said in the beginning. So that's our initial set of data. So let's perform some functions on these. Like the first one would be the SVJSON. So I would want to convert or at least show my geometry column in a SVJSON format. So when I run that query where I'm basically portraying the geometry column in its SVJSON format, you could see that this looks a little bit different, which kind of gives you a more detail on the points that are included and also mentions the spatial references. You can play around with the parameters also, with specifying what sort of JSON format you're looking for, and then it would be much more simpler. So just a quick example on how that works. And the next one is the intersects rect planner, which will help you see all the points or lines that are coinciding with your rectangular geometry, right? So we talked about it. So I just performed that normal query where I want to see all the geometries that are intersecting with my rectangle. So you could absolutely see I got some points that got back in my query. I see some line strings, and the polygons are my original rectangular shapes. That was that for that function. And the next one is the Hausdorff distance, where I am basically calculating distance between two geometries, like in the sense here, two polygons that I am considering. So one is the square and the other is another square in a different area. So you can definitely see I have received back my distance, the worst case distance between these two polygons in meters. And that was on the planar formula, right? So if I would want to do it on a sphere SRS, so that is also possible. But then we also have our another monitoring view that's now made it newly. So in my schema, I think I just have one geometry column, right? So that comes out, but in case you have multiple informations on your spatial systems in your database, then all sort of things could pop up, which is already giving you a good overview on what you have stored in your database with respect to spatial. And the next one, just wanted to give a quick overview on the centroid that we saw. So like I said, ST centroid will work on point and multi-point geometries, right, on the round earth. So let me see what would be the centroid for. So I have the calculated centroids for my geometries. Like this is a point. Okay, let's go to the multi-point. That makes it much more simpler. So we have the multi-point depicted in here. So I want to find the centroid of this, which would somewhere fall in here. So a quick example of how centroid could be calculated on the round earth scenario at this point, which is an extension to what we already have. And yeah, that was all on the demo. And moving back to my screen, I just wanted to sum up some of the benefit points that this would provide to an user from an user perspective. Absolutely enhanced spatial analysis. So you get precise measurement functions, and you can now foresee some advanced spatial relationships, right? So that's an added advantage, and it has definitely improved the data compatibility aspects because you're supporting formats like SVJSON, and you're incorporating so much on the round earth calculations. So we are also ensuring that SAP HANA integrates very easily with many GIS platforms. And we are definitely also promoting a lot of efficient data management, because you saw the new system view enhancement and the polygon clustering capabilities with the intersection, with the new intersection algorithm. So this makes it much more easier for users to manage large volumes of data and also get an overview of what you entirely have in your system. And the last point, increased flexibility with functions like st remove point and st intersects rec planner, offering you much more flexibility with the data manipulation point of view overall. So yeah, that was all I wanted to share, and some new functions to try out already. And with that introduction and overview with multimodal, I will now hand it over to Christoph for multimodal and AI, please. Over to you, Christoph.
Thank you very much, Shabana. Let me switch over. There in a second. Here we go. All right. So let's jump into the topic of what's new in HANA Cloud Machine Learning and the AI functions in our predictive and machine learning function libraries in SPS 8. Just to set the scene, so in the SAP HANA database, we have the predictive analysis library, which is our expert AI functions or machine learning function library, and the automated predictive library for, let's say, the less expert in data science, providing straightforward interface for classic AI scenarios like classification, regression, time series forecasting, or cluster analysis. Both can be used from the SQL side as well as from expert scripting languages for data scientists like Python. And then on the Python side, there's also some support for generating design time code for embedded AI application development. So basically, you can generate the HANA design time procedures for a given machine learning scenario. In the predictive analysis library, specifically in this new release in SPS 8, we have a large number of enhanced algorithms, 8 completely new, and specifically to point out 26 or 27 algorithms which have been enabled with this data parallel massive execution pattern, which we'll cover in a second. AutoML has been introduced before to HANA 2 SPS 7, but as we'll see, there are many enhancements in this area as well. To overview the enhancements, just to show the richness in different directions. As you can see, there's new functions like in pre-processing, quantile transformation, a multi-layer perceptron, a new algorithm. There is regression operators for time series in AutoML, etc., etc. So a big variety of new capabilities. On this slide, there is also a link to a blog post and the documentation with the latest features. I will show that during the demo section. So you have the direct link to the blog post and also the examples I will be showing. So let's go now into the different topic areas, starting with the enhancements in regression and classification. So new algorithm is a neural network multi-layer perceptron algorithm. Basically, we had this algorithm before, but this has been enhanced for performance and also capability, as it now allows to predict multiple targets for both classification and regression scenarios at the same time, and is a much faster and modernized neural network architecture inside. We do support improved evaluation of external feature contribution or importance by supporting a capability called permutation of the feature value. So basically, this mechanism permutates the values of the features of the different features against each other, and therefore can evaluate the real effect a feature has on the predicted values for a given model. Outlier detection is a completely new algorithm for regression scenarios, something you would do in pre-processing before building the regression model. And then there's also enhanced or improved prediction and confidence interval for regression models, which will also have for time series models in general, including the measurement of the prediction interval with a given function called interval quality, also relevant for regression as well as for time series scenarios. We introduce a new function for FairML, binary classification and regression scenarios, which aids the data scientists building a model where there is need for mitigating or management bias and potential unfairness in the algorithm, because the model is used in a context where it may affect certain underrepresented or delicate or special to be treated groups as part of the, in this case, humans who might be affected with this model. So that's a new functions in that area. We have our algorithm hybrid grading boosting trees enhanced with a series of capability for runtime performance, but also with respect to model performance in regression with new objective functions and in classification for new cross-validation metrics and in options for weight scaling of the target values if you have imbalanced classes and like to differently weight the different classes, for example, related to different cost scenarios for false positive or false negative or etc. And there's also early stopping introduced in the algorithm for, as I said, improved runtime performance. A key feature which we'll see in all the categories is this data parallel massive function execution, where basically you call an algorithm, a PAL function, but in your data set you have a column which you can think of a by group in the sense of a SQL select statement, and you can basically apply this process by this column or the values of this column, invoke the algorithm in parallel on each of the subsets in the data identified by this by group. And this is a very fast and efficient way to massively apply the algorithm on large number of subsets. In some of our SAP applications, like integrated business planning, this method is used for multiple 10,000s of parallel invocations of time series forecasting algorithms, for example. Some other enhancements are improved KNN search algorithm in multi-class classification. We can limit the output to top N classes. So if you have a large number of output or target classes, like hundreds, certainly you don't want the probability of all the 100 classes in each output, but maybe only the top 3 or top 5 or top 10 maybe class probabilities for each prediction. And then one-hot encoding has been improved with respect to performance and also memory usage, as infrequent classes will be or can be integrated into a single feature, and that improvement is also applied with different algorithms. So here's an example of the new MLP function and how it's been used on the SQL side. It's called PAL_MLP multitask fit or predict, depending on what you do. The example given here on the screen is the prediction only. I described it already in a bit, but maybe to summarize again, what's the advantage of this multitask learning setup and scenario? It's an algorithm which makes sense in scenarios where you'd like to predict multiple target columns at once, because you may have a user screen with a form which shall be auto-completed, and you have common inputs to the different target fields you'd like to populate with value recommendations, but there's also differences. So that's an advantage of this neural network implementation, as it kind of can leverage the commonalities between the different targets to be predicted, but also can differentiate for the individual target field very well. And therefore, I think is a great value add to the family of classification and regression models we're supporting here. And we'll see a brief demo of that later on. And there's also a link to a specific blog in here and also in the overview blog for more details on the algorithm. This is a brief overview of this fair machine learning functions. As I said, might be valuable in use cases where mitigating the bias and potential unfair treatment of potentially affected groups of individuals needs to be handled. And there's then different ways to do that. There's also an explicit blog about this and how this may be applied and what fairness evaluation metrics can be used to evaluate if the model is fair regarding the groups you'd like to specifically take an eye on or consider. As you can see here with the graphical screenshot here on the right-hand side, there is the false positive rate taken as an evaluation metric, where in this model we wanted to look at if the model predicts equally with respect to two age groups, which are kind of the affected groups of individuals which were to be considered in this demo scenario where we took the screenshot of, which is also described in the blog. Okay, that's the FairML function on that point. Let's step into time series analysis and forecasting. Again, a couple of new capabilities and features, also the external feature importance evaluation. So also in time series, we often have external features affecting the time series values, and therefore we also often need that external feature evaluation. What's the impact of, for example, we are in the Black Week or Black Friday week. What's the effect of the Black Friday week on sales, for example? That would be an external feature to be evaluated. And with that permutation of the features of different external factors, this can be more effectively be measured. Then there's again this interval quality for the prediction intervals, which can be applied and qualified. New and improved is the outlier detection algorithm, which provides an automated selection of the outlier detection function. There's multiple outlier scoring functions in there, which are automatically detected. And then there's also the option to use a voting ensemble of multiple of these outlier evaluation scores in order to include all the aspects of all outlier qualification in that step of time series analysis. There's also then part of the automated analysis is the detection of intermittent time series, including then missing value handling and smoothing of the actual time series before then the forecasting model is being trained. Then the seasonality test is also been improved as a function with the seasonal and trend decomposition using the LUS and STL methods, but basically on a high level providing a more robust decomposition, less sensitive to outliers in our time series data. There's also more details than in the blog and the examples about these methods. Long-term time series forecasting is a neural network algorithm enhanced with new neural network methods, linear methods here, which provide better speed and accuracy. And there's also decomposition function, which also allows for this external feature decomposition as well for this long-term time series function. And as mentioned, also the data parallel and massive execution flavor has been added to a large number of the time series functions, which we see here as well. That's just an example of the long-term time series forecasting function and its enhancements. And here on the right-hand side, we just see one flavor with the screenshot at the lower part of the screenshot, which shows the effect of multiple external features on the time series. So that's kind of what these algorithm can also provide. Beside the decomposition of trend and seasonal component, it also can, on the feature level, provide insight about the individual features' impact and contribution. One area with many enhancements is our AutoML framework and the functions in the area of general configuration of the AutoML scenario for smaller or time series based scenarios, especially where we want to maybe train multiple time series models in parallel. Again, this data parallel flavor. We need a fast forward optimization, and there the classic genetic algorithm may be too much, and therefore random search for kind of a smaller search set is made available, so that basically concludes quicker to what the best time series may be for, as I said, smaller time series scenarios. The operator selection in an AutoML pipeline can now be optimized in the sense that the operator sequence and operator connection importance is analyzed and then can be passed in as an input to the AutoML scenario. You should see that in a second as well, or can also take a look at the blog where this is explained in more detail. Fine tuning is introduced if you think of an AutoML scenario where you have set resources for let's say 300 operations, and your AutoML scenario concludes after 100. Then you could spend another 100 iterations on fine-tuning the best pipeline, which has been found by the AutoML optimization phase. Pipeline explainability has been enhanced with a faster, let's say, explanation approach. There's a visual editor in the Python machine learning client for specifying the AutoML scenario configuration, including verification of what you have defined is kind of a valid pipeline. a score function has been made available, which is certainly important. We've had the evaluation function, which included the overhead of rerunning the cross-validation of scenario. And with the score function, you can basically apply the best pipeline model upon your holdout sample or test data set in one go without additional the overhead of, again, cross-validation the model. For time series specifically, we've introduced regression operators for the hybrid gradient boosting tree regressor and linear regression. So that basically add to the time series operators and just just recently also introduced in HANA Cloud, we've introduced now also the data parallel AutoML. As I said, we may want to train multiple time series models using that by group pattern or massive or data parallel pattern on subsets identified by a grouping column that is now also available with the AutoML functions for classification, regression, and time series. And we will see that in an example in a bit. It's basically also outlined here, as we can see here already on the screenshot. When invoking the fit method, we see that there's a new parameter called group key on product level, and then as an output, we would see for each product, which is the group key, we have trained multiple models, and actually the AutoML engine proposes different algorithms with different parameters for each of the product groups. So very powerful scenario in general with HANA, that as our data is kind of stored and managed within our HANA database. And specifically, if we now want to run multiple of these scenarios, we can just identify them by the grouping ID and invoke the function directly in the database without the data required to leave the system. As general enhancements, beside what I've showed in the categories, there's a new pre-processing functions like the quantile transform for normalizing basically the input distribution to normalized output distribution. For some of the algorithms that's suitable for building more robust models. In the area of financial data analysis, we have provided two new functions: Benford analysis to detect, for example, anomalies in numerical or financial data sets. So we see quite an interest in that. And the Hal White model for customers who are interested in modeling interest rates. That might also be a well-fitting algorithm for such scenarios. In the recommender functions, the new internal multi-layer perceptron neural network architecture has also been applied to that recommender function, which provides also value and with respect to faster fitting of respective models, more robust predictions, and faster predictions as well with this new function for recommendation scenarios. Text processing functions have been enriched to some degree with a random decision tree based text classification function and stop words support with the TF-IDF function. And maybe here on the right-hand side, just to highlight, we have the data parallel massive execution support, so also for some of the other functions including, for example, isolation forest for outlier detection. The automated predictive library 2425 is supported with SPS 8, and it brings a set of features since the release of the APL library for SPS 7 in performance and in calculating variable interactions, as well as also local explanations for time series models. And the overall kind of function map here for the predictive analysis library in violet here highlighted what's the enhancements here for SPS 8. And we see there's a rich set of new capabilities in all the areas of algorithms we provide. And with always a strong, let's say, focus on classification, regression, AutoML, and time series as the major function categories. And certainly our Python machine learning client, we can make use of not only with HANA Cloud, but certainly also with the HANA on-premise release. And since the last HANA on-premise release, where version 2.16 was provided, we now provide, or he have tried to summarize all the enhancements since 2.17 until 2.22, which was released in end of September. With kind of a variety of enhancements in all the areas. So all the functions are basically talked about. You will also find examples in our Python machine learning client for that. Yeah, and with that, let's also take a live look at some of the examples. And for that, I will basically switch over to some demos. Maybe before I do that, I kind of want to hint you to this blog, which we'll also link in the notes here to the session, which again overviews all the enhancements. And in the bottom, you will also find links to the sample notebooks, which we have prepared in our HANA sample repository here. And that's basically what I will be showing. But if you are familiar with using a Jupyter Notebook environment, you can also run them all on your own. So these are the notebooks. As you can see here, if I run these cells again, I'm connected against a HANA on-premise system and can now basically start exploring all the enhancements. For example, the unified regression enhancements, and here there is a unified regression report, which, for example, gives us a nice overview on what was the actual data, what was the scoring data, and all the statistics related to evaluating a regression model. There's enhancements with respect to the Shapley report. So that's more on the report side of the actual explainability visualization. So what's the impact of different features on the predicted output of the model in general? And we'll see how that looks like for individual predictions later on as well. There's the new multi-layer, multitask neural network algorithm, which in this case, I'm applying to a diabetes demo data set where we want to predict if a patient is likely to acquire diabetes and a second disease, shortcut here PNP, peripheral neuropathy, and those typically go along, but also not go along. So therefore, they have maybe common features affecting the outbreak of that disease, if you want, and therefore this new algorithm might be a good fit, called MLP, multitask classifier here. And as we then can see, as we predict the two targets, and here we have specified the two labels being diabetes and PNP. And if when we then do the prediction, we also see output by the single model for multiple of those. If we step into the area of what's new in the area of AutoML, that's a very rich sample notebook. And as you can see, these sample notebooks are somewhat ordered by the release of the Python machine learning client, giving you kind of an overview what's new in the different releases. So you can also, using the outline, step to the topic of interest and execute the code there. For example, AutoML with explainability, or the Shapley explainer, the improved one. Here, for example, we added this use explain equals true capability. And then during the predictions, we get the reason codes, as we, at least if we also use show explainer 2, the reason code shows us now the impact of each feature in percentage on the predicted outcome score. So the predicted score is 0, and what's now the impact of column skin thickness, age, etc., on that respective prediction. So the scenario is the same. It's a diabetes prediction classification. There's examples on the regression operators and how those are used. I want to quickly move forward to again the Shapley explanations, maybe that in a second step, to the data parallel AutoML modeling. I'm working here with a dataset shampoo sales, and in this dataset we have two products, classic shampoo and new shampoo, and we have, I think, 36 months or something like that, and for each product basically have a sales figure, and we now want to build a massive automatic time series model. So that's the method class we apply here in this scenario. And then during the fit call, we set the grouping key. And as we execute the model, and you see the runtime is 2.4 seconds. So for this demo scenario, not too long. We can then see the output, and the invocation here is configured in a way that we say for each of the time series or of the products, I want the 3 best models, elite number times 3. Therefore, I see for new shampoo and classic shampoo 3 models, and we see that 0 is the best model for each of the classes, second and third best. That there's always different time series algorithm or sequence of algorithms selected with different parameters. So auto exponential smoothing is the best one, but the second best one was Brown exponential smoothing in this scenario. So really, with each of the time series, a different, and for the time series groups or product groups, a different time series function is evaluated. So that's really, I think, helpful to scale the usage of AutoML also to this massive and parallel apply of machine learning algorithm within HANA. Yeah, what else could we look into on the miscellaneous enhancements? There is a mix, I would say, of the enhancements over the different releases. Some are on the side of the data frame, different methods added, which are more related to the Python machine learning client than functions in the predictive analysis library, but typically they certainly go along, and this is basically assuring that all the capabilities of the PAL library are then also available within the Python machine learning client. One last thing here I'd like to outline is that capability of generating design time artifacts. In this example, where I would connecting against my HANA on-premise instance here, as we see, and in this case, I've built a forecast model on sales refunds on a daily basis. That's the sample data which I, in this case, demo case, have loaded to the system, and want to use this additive model forecast algorithm, which is the PAL implementation of a popular forecasting algorithm called Profit, which is very convenient as it's an automated time series forecasting algorithm in the sense of it automatically detects change points in the time series and then detects different seasonalities, and automatically and basically between each of the change points it models distinct time series. Therefore, in context of scenarios where we have frequent change points in our time series for some breaking event, for example, then the model, the algorithm detects that and can model then an accurate, let's say, sub-forecast model for that period after the change point. It also can include external factors like we just talked about. Black Week could be included as an external factor or whatsoever. So it provides a variety of different capabilities and lots of automation capabilities. Therefore, it's quite nice one to take a look at. And here we would see the visualization of the profit forecast model for that time series. But what I wanted to basically point out in that example, just to illustrate that this is possible. Certainly, we are evaluating the accuracy of the time series forecast, but that there is classes in the Python machine learning client which help with the design time artifact generation, and as we can see here, I've generated the artifacts before for a given scenario, like this profit forecasting scenario. I can basically take a look at the procedure code, the SQL code, which is generated and eventually then executed on the SAP HANA database. And with that, I basically like to go back and look into if there are any questions on the machine learning topic or the multi-model and spatial capabilities topic.
Thank you, Shabana. Thank you, Christoph. There were no questions in the chat on the greetings from Pennsylvania, India, Mexico, and from myself, obviously. I pasted the links to the blog post that you mentioned about this new ML capabilities in Service Pack 8 of HANA 2.0. I pasted as well the link to the notebooks that you used to demo. So with that, chat is kind of like clear and there are no questions.
Okay. Is there, Shabana, anything you would like to share in addition?
No, Christoph. I think this was a good session and it was helpful for everyone to know what's new, especially with multimodal and also some interesting ones with AI that you shared. So.
Obviously, they were really interesting. Like, you know, that I love this area. So I was glad that I was able to host the session. Thank you for all the insights that you shared during today's webinar. For everyone else who is just watching the recording, I will add these links in the comment section of this video as well, so that you have them for the future reference. With that, I would like to thank our speakers. I would like to thank everyone who joined this webinar. See you around. Take care and goodbye.
Thank you. Goodbye.